Hi everyone, I am so glad to be here in the NLP Summit conference. I will present text-to-topic. My name is Moran. I am a machine learning manager at Booking.com. So a little bit some introduction. So as I said, I'm a machine learning manager at Booking.com. I'm doing my PhD studies in information system engineering. I'm researching NLP aspect in temporal graphs. Previously, I was data science team leader at Diagnostic Robotics, and I'm in Booking. One of the main reasons is because I love traveling. So just for you to be familiar with our platform in Booking.com and what I am doing there. So there is a platform in Booking called a Content Intelligence Platform, CIP, which is the centralized marketplace for enriched content across Booking.com. And this is the place where everyone in Booking can consume different content features for different models. And in this platform, we productize our model text-to-topic, which I will, in 1 minute, I will present. But this is a marketplace where all content features are can be consumed across Booking. So what is this platform? So for every kind of input of content, for example, an image or set of images, we can predict using different models some outputs. So for example, we can predict the classification of the image, if there is a pool in the image, if there is sunbed, sun umbrella, for example, in this specific image, what is the quality score of the image, what is the focal point, the main point of interest of the picture, and we can use this focal point for cropping, for example. What is the embedding of the image that can be used as features for different models, a caption of the input, is it safe to present in Booking website, and this kind of output. And for this different output, we save the predictions in CIP for everyone to consume for all images in Booking. And same we are doing for text. So for text, for example, we have different guest reviews in Booking. This kind of real examples of guest reviews. And for each one of the review, we want to save different outputs. For example, what is the classification of the review? So for example, in the review that is bold, you can see that there is pubs and clubs in the street and very noisy at night. So we know that there are food and drinks options nearby, for example, and quiet area is a topic that's presented in this review. We can say the quality score of the review, like if it's like a high quality review in terms of the semantic and language. We can have an embedding representation for the review, again, to consume for different models. If it's safe to present, and what is the sentiment of the review? Is it positive? Is it negative? Is it neutral? And all of this kind of output are there to consume using the content intelligence platform. So the main idea is that it's centralized place to consume enriched content at scale, at any level, image, text, property, and we are doing backfill. There is some batch processing to do backfill for all Booking images, for all Booking content, for all Booking reviews and other text, and we can save it offline and then consume it for different needs. And there is online live processing for new content that is coming into Booking. And we deal with a lot of like velocity and batch processing to do it fast. And for any new model, we do the backfill within a few weeks, and then it's ready for consuming it. So this is CIP, and I am machine learning manager of this platform, and we enrich this platform with a lot of models. And one of the models is text-to-topic. So what is text-to-topic? So the main idea of text-to-topic is that for any kind of review, we will extract different topics. So for example, in this review, bed and pillows not comfortable, small room, cold when we arrive. This is a real review. And we want to extract that the topic bed comfort. We can see that there is this kind of topic in the review. The in-room temperature is mentioned and the room size is mentioned. So the main idea is that for every kind of text, we will extract this kind of topics. And we want to do it for any data source in Booking, not just reviews. So one of the data source, the main data source is reviews. As you can see here, in the platform, in the website that you can left a review for any accommodation that you visit. But there are a lot of other kind of text in bookings. For example, the partner side. So again, as a guest, you write a review on the accommodation that you visit, but the partners, as the other side of booking customers, are writing reviews on booking platform and leave some feedback in the partner hub framework. Another kind of text in Booking is the question and answering. A lot of guests can left some questions for the partners to answer, and we want to analyze these questions and answers as well. There are a lot of open search queries that you can write in the Booking open box when you search for accommodation, and you can do some search in mobile using the microphone here and record yourself your search, and then we do a transcription for the record and get the query text from there. So we want to know the topics that people are looking for and from using these queries. Another kind of text data source in Booking is the travel community, which is kind of a blog that everyone can write a post of its travel and recommend some good locations in the destination they are visiting. So this is another kind of text data source. So the main motivation of this model is to understand what are the topics using all these data sources, and we want to know what are the topics that are important for our users, and to use this kind of information to improve the end-to-end experiments of a user, of a guest using a Booking platform. And one of the use cases to do that is to get themes-based reviews. For example, we can get reviews discussing on romantic and nature and use it to personalize the customer journey. So if a customer is looking for a romantic place, so I will recommend him on properties where I can see the romantic being a very important topic in the reviews of this property. We want to understand the most important facilities for our guests, and we can present in each property what are the most important facilities that guests are talking about. We want to allow users to filter reviews by specific topics, so we can see, so the user can see the review that are discussing about the beach, about the kitchen, and so on. We want to find the significant attribute and endorsements of a property or a UFI using the reviews and the question answering text. And another use case is detecting fraud messages. For example, that there are some fake properties that trying to taking some bank details of the users. So we want to identify this kind of topics as well, and sexual abuse or violence in reviews as kind of and to moderate it. So this is an example of how we can use text to topic in Booking. So as you can see here, the user can see their search result for properties, and here you can see some destination recommendations in Booking, and above you can see some topics and the user can get recommendation based on this topic. So I want to look for a destination with amazing views. So then the user will get the destination where we see this topic to be relevant and be very important. And again, and same for the property side, where guests can find properties that have specific topics. So for example, friendly stuff or delicious breakfast. So we can filter only properties that are very highly positive in reviews discussing on these specific topics. So how we can build a model to support all of these use cases and this motivation. So we want to detect the topics accurately in a wider coverage, and we don't want to define a specific set of lexicon per topic. We don't want to specify that romantic keywords for romantic, for example, is couple, sunrise, sunset. We want the model to learn this kind of relationships between the keywords and the topic. We want to be able to add additional topics more easily. So if now we have new use case and new topic list, so we want to add it to our model with no effort. And we want the model to be zero shot, to enable zero shot. And we want to fine-tune the model for the tourism domain and the relevant topic of the tourism domain. And we want the model to support multi-languages, as we have reviews in a lot of languages. So the main architecture of the model, I will present few architectures. One of them is cross-encoder. So what is cross-encoder? So basically what we can do is take sentence 1 and sentence 2 as a shared input, and insert it into a BERT layer and get an encoding for these two inputs. And then insert it into a classification head and predicting if the sentence 1 is similar to sentence 2. What is the probability? So what we are doing with booking data, so we take each text. For example, we have best private pool in room was good and nice breakfast, and the topic itself. And we have positive samples and negative samples for these pairs. And then we can insert them with a separator between them. So we have the first part of the sentence, then separator and the second part of the sentence. Both of them are inserted into BERT model as one input. Like we have the first text and the topic and separator between them. Then we take the CLS that represent this sentence, shared sentence, as representing the relationship between the two. And then we have a fully connected layer to predict, and then a sigmoid to predict if the text and topic are related or not. So we have binary cross entropy loss function here to predict if the topics and the text are related or not. So this is the main architecture. But we can do different kind of architectures. One is by encoder. What is by encoder? Instead of having shared input, we have separate inputs. So we have one head for the sentence, for the text, and one head for the second sentence. And each one of them, we insert each one of them into BERT. And then we do some mean pooling, and then we have the sentence 1 embedding, the sentence 2 embedding, and then we can calculate some cosine similarity between them. So again, if we take a look on text and topic, so we have the text, and we insert it into a BERT. Then we have the embedding using the CLS token. So we take the embedding of the CLS token, and this is the embedding of the text. Same we do for the topic, and then we have the embedding for the topic. And then we can do different things with these two embeddings. One is to calculate the cosine similarity, and this will be the loss function. So we will calculate and we will normalize each one of them, and then we will multiply them, and this is how we get the cosine similarity. And then we have the positive and negatives, and we want each one of them to be optimized with the binary cross entropy. And we can, instead of the CLS token embedding, we can use mean pooling. We can take each one of the tokens in the text and each one of the tokens in the topic and do a mean pooling and get one embedding representation for each one of them. And then we can do the same, multiply them, normalize, and then have the prediction with the binary cross entropy. Another way to do that is to concatenate them. So we can take either the Cls token embedding or the mean pooling across the tokens, concatenate them, then we can have a fully connected layer and then a sigmoid with binary cross entropy loss. So this is different architectures to do the same, but in a second we will see the advantages and for each one of them. This is a very nice paper discussing on how we can train this kind of bioencoder. So if we don't have a lot of data, take data, we can do self-supervised training. So the main idea with self-supervised learning is to take different sentences of text and topics, or for your domain, like if there are some text that you want to find similar text to this specific text. So the main idea is that you can create list of positive pairs of different text using hidden dropout mask in 2 forward passes, meaning that you can take the same text, then insert it into different dropout mask, and then get the noisy representation of the same text. And this is a positive pair, because the noisy representation represents the same text. So this is how we can create a positive pair for the training. So this is how you can do unsupervised training for bioencoder and then use it for your task. There is another way to do supervised learning with NL, and the paper suggests NLI dataset with the entailment and contradiction to present the positive and negative pairs of sentences. So what are the main differences between these two architecture of cross-encoder and bioencoder? So cross-encoder trains the model with the text and the topic as one input. And the main advantage of this approach is that the attention layer will learn the relationships between these two inputs. So we have it as one input and we insert it into one BERT together. And then the attention layers within BERT will learn how each part of the sentence of the text is related to the topic. So for example, if we have the swimming pool review and the swimming pool topic, so it learned the specific location in the text that is related to the swimming pool. So this is the main advantage of the cross-encoder. But what we don't have here in the bioencoder, because we get for each one of them the embedding, and then we calculate the constant similarity between them. But we can't have the attention to learn the relationships between them. But the main advantage of the other architecture of bioencoder is that the inference is much faster, because we can save in inference time one time the text embedding, the topic embedding, and then just to do the multiplication between them. So if we have the T number of topics and N is the number of text, so using the bioencoder, inference will be just T plus N, because we need to embed just the T and the N, the topics and the text. Using the cross-encoder architecture, we need to embed it will be we need to embed the cross between them, because it will be for each topic and text we need to encode, for each pair we need to encode the embedding to get the embedding. So this is the main difference. And I wanted to discuss about another interesting things that you can use during training and inference, and it's dynamic padding. So basically, the standard approach when you do the training on sentences is to take the data set and have a max length over the different sentences, and then use for tokenization this max length. But actually, we can do dynamic padding. What is dynamic padding? During the training, for each batch, we can calculate for each batch the max length. So if you use Hugging Face tokenizer, for example, using padding longest, will bring the training to be like on our data set, it was multiplied by 5 faster. So it's very crucial to use. So I recommend on this. But so the dynamic padding is basically the main idea. The main idea here is that for every batch, we do we use the tokenization on the max length of the specific batch. But we can do even better. For inference, we can sort the data by the length of the sentence, and then each batch will be optimized to be in the same length of the other sentences in the specific batch. Then we have for each batch very low number of length. So we use it in inference. We sort the data. We don't do it in training because we want the batch to be diverse and to represent different kind of length. But and that's why in training it's random. But in inference you can sort the data and then do the inference batch by batch. So let's go into evaluation of the models. So how we evaluate the model. So here you can see some dashboard, some plots, for example, for the staff help and support. So we have topic of staff help and support in Booking. And we can calculate different metrics. We can calculate the confusion matrix, or you can see the accuracy, and we can calculate the precision and recall curve, the ROC curve, and some plots of the prediction of the model, and see the distribution of the positive and the negatives on these probabilities output of the model. And then we can see what kind of threshold is best for us to differentiate between the positive, the green, and the negatives. But if we want some metric to represent all the topics, so we use other kind of metrics. So for to represent each topic, we calculate average precision. So for each class, for each topic, we calculate the area under the precision recall curve. So this is the average precision. But then we use 3 other metrics to represent all the topics. So we have the macro mean average precision, which is actually it's unweighted average. So for each one of the topic, we give the same weight. And then so L is the number of topic, and then we average the average precision over the topics. The weighted mean average precision is to take each one of the topics with a weight, depending on the number of positives. So if, for example, we have some topic with a lot of positive, we want to give him higher weight. So we do a weighted average across the average precision for each topic. And we have the gap, the global average precision, which is actually to take all of the topics together and to do a global precision recall curve for all the topics together. And we have, again, precision, what kind of topics we identify and what not, but we are treating it in the same curve. And the gap is the area under the curve of this global precision recall curve. So let's take a look on some results. So here you have some guest review, for example. So very nice staff. Thanks, Sophie, at the reception. So staff and health support and the reception topic was identified with this kind of with these probabilities. That is in a street with pubs and clubs. This is real guest reviews. Very noisy at night. So food and drinks option nearby, quiet area. It's worth to mention that the topics are identified for both directions. So if we have quiet area as topic, we identify both quietness of the area and noisy and if the area is noisy. So this kind of topic represents both directions. Value for money, no intercom, and very expensive for what it's worth. Located next to train station, you will notice, so public transport option nearby. And here you can see the results of text to topic with the different metrics that I just described. And we compared here the text to topic is cross-encoder architecture, which work the best for us. And we compare it to Muse, large model, which is a universal sentence encoder model, unsupervised one, which is very familiar to use for this kind of task. And we can see that we have a very high improvement over this kind of baseline. And here you can see a sample of our topics divided into different categories. So what kind of topics we are identifying, and what is the average precision results for each one of the topics. So we have for food and dining, breakfast, food and drink option nearby, food value for money, and the location, shopping area, central location. But we got very good results for each one of the topics using this kind of model. And very interesting things to mention is the zero-shot capability. So as I mentioned, we want to be able that the model will perform well on zero-shot, on new topics that the model didn't train on. So these are two examples of new topics that wasn't part of the training. So allergy-free room and nature peaceful. And the model can actually learn the relationships between the text and this kind of new topic, because the course in encoder architecture allowing us to insert the text and the new topics as input, and then we can use any kind of topic as an input to the model, and this is why we enable zero shot. So as you can see, the model learns not exact match keywords for the specific topic. So some dog should have some dog-free rooms for allergy sufferers. So and then we understand that there is a specific request for allergy-free room. And all of the text here are very related to this kind of topic, discussing about dust and allergies in the rooms, for example. And the other topic, nature peaceful. So a lot of discussion about peaceful, surrounded by nature reviews, and we see very good results on this kind of zero-shot ability. So now we have this kind of topics, and I wanted to discuss a little bit about the data collection. So we have we collected the data on 50 topics, but within this curve you can see what is the number of positive per topic that is required in order to get the results. So you can see in the red line the map macro metric, and in the blue line the map micro. And we can see that with zero, like unsupervised approach, we can get the result that I showed you in the two previous slides. But as long as we got more positive samples and more annotations, the curve is increasing, but we get some flat area. And this flat area is like we see what is the number of enough positive example per topic. And we can use this analysis in order to collect more samples on new topics if we want it to be more optimized on new topics. But we don't need a lot of data. We just need 100 positive examples per topic in order to get good results in comparison to unsupervised approach. So having that in mind, we are using AWS SageMaker for collecting annotations. And we do it in smart way and not wasty way. So we use the model that I just showed you and the predictions for each one of the data sources. So if we want to collect annotation on new kind of data source, not just reviews, so partner hub, partners feedbacks, question answers, and posts from the travel community. So we can use the model to predict what is the top. We can predict per topic what is the top K texts that are relevant for the topic. And then we can assign, here you can see some example for AWS, for each kind of text, what are the relevant topics that we want to annotate. And instead of having all, if we have 300 topics, instead of having all 300 topics multiplied by a lot of text, we can do partial labeling and just label the most probable, the topics with high probability to be relevant for the text. And this idea we use in order to collect annotation in a smart way. So we use the first model prediction and we assign text to questions that have the relevant topics that was mentioned, that we collected from the model. And we do some randomness, we add some negative sampling, random negative sampling, and this is how we collect more annotations for new topics. So to conclude the session, we build a supervised topic detection model using multiple data sources. So this model is very generic to any kind of text, and can find relevant topics that are discussing in any kind of text. We show how we model it with different kind of BERT-wise architectures. Each one of them enable us to, each one of them has zero-shot capabilities. We are doing the data collection, and we discussed about data collection challenges and optimization. So we optimize the data collection using this partial labeling on the high probability texts that are relevant to specific topics, and then we can end randomness, and then we don't have to collect so many, and we collect the texts that are relevant for specific topics. And we can add data augmentation using if we have only annotations in English, we can translate this kind of text and have more kind of text in other languages. And we can do self-supervised approach, as I showed you in the paper, with using dropout or this kind of approaches to do self-supervised training and not collect a lot of data. Thank you. That's all.